Audio is very bad, all right? Testing, testing. Did that work? Okay, well, I really don't know what happened there. I really only have one microphone device plugged in. You saw on the menu, there was only one device, so yeah. Okay. That was very strange. Yep, 2018 technology. Well, let's get started. I don't think this is going to be a particularly long demo, but I wanted to do it just to keep people updated with what's going on. Just like I've said the last few times, the main thing that's going on is robustifying the compiler, testing more corner cases, finding bugs, fixing the bugs, simplifying the code. So, we're not in a phase of feature development right now. We're in a phase of hardening. But that said, there are some features that have been added. Smaller features, not big, high-powered features, but more things to improve the day-to-day ergonomics of programming or to solve just very specific issues that we've had. So I thought I'd just let you guys know what those most recent ones are. So, as always, I've got a program. As often, it's just a text program. It's not graphical. I'm going to compile it. And you'll see the first thing that happens when I compile it is I get some deprecated procedure warnings. And that is a feature that we added. And, just like you can mark a procedure as foreign or whatever, you can mark it as deprecated with some comment string. People can still call this procedure, and it'll still work and stuff, but it'll generate a warning. So this is do some job. We're calling do some job, right, with a string, and we get a warning, and we call do some job x with a string, and we don't get a warning, right? So there's a warning here for do some job, the call to do some job. There's not one to the do some job x. And there's more warnings later because I'm using message box A, and I'll show you why. But the reason this whole thing came up is, we have all these Windows bindings, and we've got a 60,000 line game at this point that used a bunch of Windows libraries, as well as some programs and stuff, or some libraries. And we came to a point where we wanted to make it all UTF-8 clean, or Unicode clean, which in Windows, anytime you interface with the Windows API, it has to be a 16-bit Unicode. So we had to systemically hunt down all these procedures with the A versions and change them to the W versions. And we figured, like, hey, while we're doing that, well, in case we miss any, we want to mark them so that any program that's been sitting around that we haven't been paying attention to, if somebody compiles it in 3 months, it'll issue warnings and tell them that they shouldn't use this anymore. In this case, we're actually putting these deprecation notes. Actually, how can I be more specific like this? So you could do very similar functionality to this, or exactly the same functionality with a compile time meta program like we've demoed before. For example, we have this check library here, and if something is tagged as deprecated, you could check for it with a marker or something, like a note that says deprecated. But this felt important enough that we just wanted to include it as a core feature. It just felt right, because maybe you turn off your compile time checking sometimes. Maybe the checking that you're running is not written by somebody who knew about the library that you're using, or maybe the person who made the library that you're using didn't want to write custom compile time checks because that's a more involved job. But it's very easy to tag things as like, hey, don't use this anymore. So that's a very simple feature. It exists. Do we have a compiler option to treat warnings as errors? We do not currently. However, I don't think it's as necessary here, because the warning culture is very different here. Like in C and C++, you get warnings for code that's just wrong, and here you don't. In fact, I think this is only the second warning we've ever added seriously. The other one is not all control paths return a value, and the only reason that's a warning right now is that we don't have perfect data flow analysis. Well, we may never have that. So it's not like C++ where there's hundreds of warnings. I don't want to go into a culture where there's hundreds of warnings, right? I think, and so this is a little bit maybe contradictory, but I would rather that most warnings happen in the compile time checks. It's just that for this specific thing, because this seems like a thing that everybody's going to want to do globally, like everybody wants to understand what this means. Whereas if you put a note on things to be compile time checked, that's more like a local dialect than like a global part of the language. That's the reasoning behind making this a feature. Okay. Let's go back to the demo. So that's the first thing. It's just two simple procedure calls. Second thing, arrays. It's for a long time seemed like you should be able to treat arrays as Booleans in certain times. Like I wanted to be able to say things like, if A is an array, I wanted to be able to say things like, if A, do something else, right? Of course, an array is essentially a struct. It's got, a count, number, and a data pointer, and the exact format of that is different depending on what kind of array it is. And for something like a constantly width array of literals, then all of those things are implicit. But all of those cast a Boolean. So here I've got a situation demonstrating that, where I've got, here's an empty array of floats that's like a static array, Here's an array of floats that's an unknown size at runtime array. And then the same things, but these are both empty and these are both not empty. And so I cast S1 and S2 to bool and S3 and S4 to bool. And we should run this. Okay, when I run this, a couple of message boxes are popping up. Those are made by the program. We'll get to those later. So the actual output, so we had our deprecated procedures output, and now we've got our casting results. So S1 and S2 cast to bool as false, and S3 and S4 cast to bool as true. Now, these are not implicit casts. It's important to note. You can't pass an array to a procedure expecting bool. You'll get a compile time error, and we'll illustrate that later. I'm kind of saying this out of order, but the only time it implicitly casts is inside if. So if, in general, has a thing that we internally call lax conversion to bool, that only is active inside if. So you can get implicit conversions to bool inside the conditional clause of an if and nowhere else in your program. And why is that? Well, it's not really a language theoretical justification. It's just that, you know, being able to say if whatever in a terse way is a part of the C programming language that's very nice, and we would like to preserve that while having much stronger type checking throughout the program. Okay, now, this cast to bool does const expr evaluate when that makes sense, and by which I mean at compile time, if you know the array at compile time, then you know whether it casts to bool as true or false at compile time. So here, we're using this isConstant primitive, which I don't believe we've ever shown before, but this is a built-in like type of and size of and all that. So C1 is asking whether this expression is constant, this cast to bool of S1, right? So S1 is a fixed array. C2 is asking if the cast to bool of S2 is constant, and S2 is actually unknown at compile time, right? This is a runtime array that can change. And so C1 is true and C2 is false. Now, why do you care? Well, in a language like C++, you really care a lot whether something is const expr because it determines whether you can do most template metaprogramming with it and stuff. In this language, you don't care nearly as much about whether things are const expr because you have run directives and you can run arbitrary code at compile time. So, you know, you just run whatever. But sometimes you do care whether something is a constant. For example, you can have a procedure like f here, which declares the value of x must be known at compile time. Well, why is that? Well, we're just doing other things in the procedure. Like, so we're declaring this b that's also constant that's not x, right? So this x has to be known at compile time. And then we're going to not x, which also has to be known at compile time so that we can set b. And then there you go. And why would you go through these shenanigans to have something known at compile time? Well, maybe it leads to better optimization, right? You can do a static if based on this value and, you know, include or not include code, or code browsing at compile time at the user level may be able to look at this procedure and have more information about it than it would, you know, if this $sign weren't here. So anyway, we've demoed this many times in previous demos, but with a procedure like this, you can only call it with a known value, right? So if I call it with cast to bool of S1, then that actually works. What does it do? It says print known at compile time b is true. Now I have this commented out, and that's because if I try to compile with this, it'll complain. It'll say argument declaration requires value bake, but this expression is not a bakeable literal, right? And the reason is because that array is not known. You know, we might actually do more inspection on it later and try to give a better error message even, but that's a pretty good error message. Okay, so now, like I said, arrays do implicitly convert inside an if. So you can say if A, print A is true, else A is false, same with B, right? So both of these are going to be false because we made these two different kinds of dynamic arrays and we didn't put any values in them. So A is false, B is false. But now we're going to add something to A, and we do the same thing, and now A is true and B is false. B is false simply because, you know, the count on B was set by assigning to A way back when, and you know, even though we've assigned to A, B doesn't know there's a member in there, right? But we're going to forcibly bump B's count, and now we're going to print it again, and now B is true. So it's just a nice way. Not everybody likes this shorthand if. I think some people on the witness team don't like it, but I really like it. Like when I program in C and C++, I do this all the time. It's just, it makes sense in my brain. So I wanted to make it work for arrays as well as everything else. And here's just another example of not implicitly converting to bool. This is going to be different from this thing that I previously showed. So this is about the conversion being constant or not, right? Whereas this is about whether the conversion's implicit or not. So we have something called boolfunc, which I put up here for some reason. And there's no $ in here. So this is just a regular procedure that evaluates at runtime completely. And we're just printing the value of the parameter, right? And if I try to call this just with A directly, right, it'll complain, right? So it says we wanted a bool, but we were given an array of int. So that's just demonstrating that this implicit conversion that works here does not work here, right? But if you cast it, I can do the same thing and cast it, and it works, right? Boolean parameter is false. All right. Now, next part. Arguments after verargs. So we've had verargs procedures for a long time. Actually, let me check questions. Do you have any examples in the Sokoban game where you made use of the const expr that you couldn't handle another way? Yes, it is beyond the scope of this demo to go into that. Does lax bool conversion happen for other bool contexts like while or ternaries? We don't have ternaries. We do have while, and actually, yes, lax bool works there as well. I said it's only in if, but it's in if and while. I think that's it. Because our for loop doesn't work the same way as C++'s and C's for loop. We don't have a condition. We don't have a continue condition in our for loop, right? We just for over a range or an array. All right. Are you able to write something like while a print a sub 0 array remove a sub 0? Yes. Yes. After the demo, we can try that out if you want during the Q&A. That should work unless there's a horrible bug, in which case we'll fix the bug. A few days ago, you had a bug where you were accidentally passing a type into if, and it was cast to true. I assume this was another lax bool. Why do types have a truthiness? Is it ever sensible to call if on a type? We need to see how it comes out in the culture of metaprogramming. Almost every type evaluates to true, but void evaluates to false. And people might use that, but that said, maybe they won't use that, right? But I feel like it's not clear. So it's not a good idea to make determinations about subtle things in a language design like this unless you have a lot of experience programming the language, which nobody does, because I don't even have enough experience to make that call. So what I would do, so first of all, when I made that bug was the first time that it even occurred to me that that might be an error that people are prone to making. And so now that we know that, I think the next step is to put that in the check library, right? So you can put in there like, oh, if somebody in an if or a while has something that evaluates to a type, then let's warn on that, or error on that, right? I think that would be a reasonable thing to do. Actually, if Abner's still on, put that in the notes for us to do it, because I think it's a good idea. but not building it into the compiler because I don't exactly know if that's the right answer to avoid that, right? So we'll see. We'll see. But I don't like to make determinations about things too early. Oh yeah, Abner's still here. Okay. Let's go on. Arguments after varargs. So as I was saying, we've had varargs for a long time. They're nicer and cleaner than C and C++ style varargs, but like C's varargs, they had to be the last argument of the procedure, and it didn't. It was disallowed to have anything after it. And a lot of the reasons for that was just historical, like that's just, the languages were influenced by work that way. Of course, the reason they did it that way is because you couldn't really, because the way the arguments were passed didn't really allow doing anything else. But here we can because we know more about the arguments, right? So we ended up in the programs that we're writing having a lot of use cases where we wanted to be able to just start to make a procedure where you just start passing arguments. But then sometimes you might want some configuration options that could go after the varargs that are optional arguments. So one of those is concatenate, which I'll go to. Actually, it's in string now. Yeah. Oh, we just called join. All right. I think join Ignacio wrote and concatenate I wrote, but they're the same thing. He rewrote the string library lately. So anyway, this takes 3 arguments. So there's an array of strings that's varargs. So you can just start typing strings, and that'll get put into a varargs array that you can reference down here. And then a separator, like what to put in between all the arguments. And by default, that's the empty string. So if you pass this with just a bunch of strings, it's just going to smush them all together. So here we're just doing that. We're saying, hi there, my main man, and we're doing concatenate and then printing the result. And we get, hi there, my main man, right there. So that's the default behavior of concatenate. But maybe you want to put a separator, like maybe you're making statements in a program and you want to put semicolon new line after every line because you're writing something that generates code. Or maybe you want to put a comma between things, but not after the last argument because it's comma separated expressions, right? So you can also have this Boolean of like, does the last thing have the separator or not? So before, people who are watching the programming streams saw that before we had this ability, I tended to have a whole lot of variants of concatenate to do hard-coded things because we didn't have a way to put things after the varargs. And if you force people to put things before the varargs, then they're not optional. So we cleaned up the vararg system internally so that you can have things after varargs. So here's hi there, my main man, with a semicolon new line, right? Maybe it shouldn't be called between because it can also go last. Maybe separator in the join version of it is a better, although separator and terminator are different. Anyway, whatever you want to call it, we're putting semicolon new line, and we didn't set the Boolean, so it's happening after everyone. So we have hi there, my main man, right? And then for the third one, we've got commas and not a thing after the last line. So there we go, hi there, my main man, and it's all the same procedure doing this all 3 times. So that was a nice boost to varargs. Now, varargs procedures are nice because they're very versatile, because you can call them just by listing the things out, or if you already have an array, you can just call it with the array by using this, right? So here's an array, it's just an array of literals, and we're just gonna call concatenate on that, right? So now we've got hello, sailor, how are you, with question marks after everything, because that's a question mark. So there's a way in which varargs are nice because they're more versatile than non-varargs, actually, right? Because you can call varargs either by putting a bunch of arguments or with an explicit array. Whereas if there's an explicit array, then the caller has to put the arguments into an array somehow. You know what I'm saying? So there's this suggested convenience that we wanted to take advantage of more often, but couldn't, because you couldn't have more arguments. Now you can have more arguments. So we're going to see how this shakes out. And I may just experiment with making procedures that wouldn't normally be varargs have varargs, and just see if I like that flexibility in the way of calling them or not. We'll see. Is there a thing that says here's where the named arguments end for when you pass more args than the total number of args? The way it works is when you get to a varargs argument, everything after that belongs to that varargs array until you use a name to break away from it, right? So here, the reason man is the last varargs is because we said, okay, now we're on this different argument now called between, right? There's no non-named way to do this. So you can't like put some symbol in here that says, let's go to the next argument. I guess we might consider adding that, but I'm not really sure how much utility that has. It might just be annoying. But maybe I misunderstand the question. Does that conversion from array to varargs only work for constant arrays? No, that works for any array. It works for dynamic arrays and anything. By the way, if you tag questions with my name, I'll see them more clearly. See like some other people are doing. If you don't do that, there's just a lot in the chat, and I probably won't see your questions while I'm trying to talk. Does passing an array through varargs with the dot dot run the risk of overflowing the stack with large arrays? No, because what gets passed when you say dot dot is just a 16-bit structure. It's got an 8-bit count and an 8-bit data pointer, right? That is what varargs arrays always turn into when you pass explicit arguments, right? What the compiler does in this case is it makes a little array object that's 16 bits wide. It sets the count to 5. It sets the data to, an array of strings, and then it drops all the strings in there, and then it passes it, right? So varargs are slightly slower than a regular calling convention because you're copying things into an array, whereas in a regular call, the first few arguments are going to go into registers. But that's not slowness on the. Most people don't care about that much slowness, right? That is still blazing fast by modern standards, so it's totally good. But if you were to go make every procedure, like I said over here, like, oh, we might make more things varargs. If you make everything varargs, you probably do take a small performance hit. I don't know, it doesn't make sense to make everything varargs, but some things maybe. Can named arguments be out of order? Yes, they can, of course. There's a whole demo that you can go look at with the named arguments. What about checking to see if the type of the thing after the varargs matches the type of the varargs? I don't want, no, because I don't, like I want the programmer to very clearly understand what is happening. I don't want invisible magic to happen, like, oh, now we switched off the varargs because I passed a thing of the wrong type, and then the compiler searched for the named argument that happened to have that type, and there was one. No, that's not good. We want to be very strict about, like one of the things that makes this language nice is that the programmer clearly knows what's going on. Even though we have type inference, for example, we limit the type inference to a very simple feed-forward scheme where magical things aren't going to happen and surprise you. And I want that philosophy to happen everywhere. So here, once you start varargs, you are varargs until you explicitly say we're no longer varargs. There's no magic happening. And that's good because you want to be able to read the code and understand it if you didn't write it also. You had an example earlier with 2 arrays. Did B equals A copy the array, or does B point to the same thing? I found it scary that B didn't increase in count if they point to the same memory. No, B was not a pointer. B was a different kind of array. And what it was its own count and its own data pointer. And the data pointers were shared. Once you get used to the language, that's totally fine. It's not confusing. But no, it wasn't an array reference. It was a different kind of array pointing to the same data. There's a whole demo on YouTube that explores that. Are multiple varargs groups possible or reasonable separated by named arguments? We decided not to do that. Not yet. It's certainly possible, especially since we revamped our calling, our type checking on our calling. We can have an arbitrary number of varargs arguments. The question is just, is it worth the complication of putting that in the compiler? Like, does that matter? Is anyone going to use it for anything? If you add a symbol to n varargs, it would naturally allow multiple varargs. Yeah. Are functions inside structs allowed? What do you mean by inside structs? You've got to be more specific about that question. That could mean several things. All right. Let's move on to the last section of the official thing, and then we'll be fully in Q&A. In working with C and C++, we're doing more and more calling out. We used to just call out to C. Ignacio lately has implemented a library that does name mangling for C++ calls, so we can call out to C++ now. There's, of course, caveats to that, because C++'s data structures are way more complicated and annoying and difficult, especially if you're using templates. But if you know the memory layout of your data structures and stuff, you can call out to C++. But until recently, it has been a little bit more annoying to do that because of the following fact. Strings in this language are essentially a struct. They have a count and a data pointer, right? So they're a little bit more like, well, I don't know, a lot of programming languages have, I don't remember. Anyway, they're not zero terminated like C strings is the important part, right? This data pointer points at some data that can contain zeros as part of the data. So you can load a binary file into a string, for example, and that's very useful. Or if you load a like this string hello here, down here, prior to today would have been a length 5 and not had a 0 after it, right? So if you wanted to interface with something like C, well, okay, before I go on, I'll say this, of course, isn't the only thing, right? We've demoed before that we have packed versions of strings that use less memory and so forth, like the relative pointer strings. But for simplicity today, we're just going to talk about this one. I've got a little example here of what you used to do if you wanted to interface with C. So this part here is I'm just making some string dynamically. Like I'm starting with the string hello, and I'm adding it to an array 5 times. That's what Emacs, that's what that does. And then I'm calling concatenate, just like we said before. And now body string is hello 5 times. And say I wanted to call message box. And message box, you give it a title string and a body string. Well, those need to be zero terminated because that's what Windows expects. So we had this thing called temp C string, which would allocate temporary storage, which you don't have to worry about freeing, provided that your application correctly deals with temporary storage. You don't have to worry about freeing individual strings, so that's very nice. So we just fire and forget temp C string, and then we pass those, right? And, well, let's just show, whoops. So that's what happens. We get hello, and then hello, 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 hello. So that works, clearly. Now, this has a runtime cost, of course, right? Because like I said, to make a zero terminated string, you can't use the same memory as the old string because like that byte after that string is probably being used by someone else. You can't just jam a 0 in there. So, you know, you have to copy the string with an extra byte and 0 terminate it. And okay, it's in temporary storage and not malloc, so that's a lot faster, but it still has a runtime cost. And I figured out relatively early on that for compile time string literals, which are what you want to deal with a lot, you actually don't need a runtime cost because you can put the 0 in the string. So here we're calling message box with you know, one to cross beams gone out askew on the treadle, and with message as the title. And so we're putting \0 to explicitly 0 terminate this string, and we're putting .data on the end because remember, this string literal is of type, you know, this, which has a count and a data. So to get the pointer, you had to do this, right? And again, we're speaking about older code from past months. It all had stuff like this, right? So if I click OK on this message box, we'll get this next one, right? So that's great. So we're terminating the string, and then we're explicitly getting the data pointer to pass it to C and C++. But that's a little bit tedious and annoying. It makes this a little bit harder to read than it already is. And so, you know, just to illustrate a few more examples of that, I have a stb printf here where I'm printfing into some data, 3 integers, and the format string. Whoops, I screwed this up. Wow. This is a giveaway that this doesn't work anymore the way it used to, but this is supposed to all have 0 terminations. So you would have had to 0 terminate the format string and put .data to print these integers, right? Or if that's not so bad here, but if you're printfing a bunch of strings in a row, you would have this \0.data a lot of times in a row, and it especially makes things like the empty string hard to read and so forth. Hopefully you get the point. Now, that said, my philosophy was like, well, you probably aren't calling out to C or C++ that much, so it's not that big of a deal. But it occurred to us that it's actually relatively easy to fix this for the cases of string literals, right? So what we decided was, okay, look, for something that has a runtime cost, we're not going to automatically convert that. But if you have a compile time string, we can 0 terminate it because compile time strings are just living in memory somewhere. And even though you know, we're explicitly determining the length by the number of bytes between the quotes, we can easily just stick an extra 0 after that in case you want to pass that to C or C++. So we now have the convention that string literals will implicitly cast to pointer to U8 or pointer to S8, right? Where this is, you know, unsigned 8-bit and this is signed 8-bit. So our examples from up here, right, become this again, and they're much cleaner, right? So here we don't have our \0s or datas, and here we don't have our \0s or datas. So of course, if I hit OK on this, we get another message box. It's the same message box, and that's this one down here with the cleaner code. Now this works with you know, you don't have to be calling out to C in order to use these implicit conversions. So here I've got a routine called print bytes that assumes a C-style 0 terminated string. And we just say, while true, get the value, increment the string pointer, print the value, and break if it was 0. So here we go. This is hello sailor in bytes, and then the 0, and then we're done, right? Now, of course, like I said, that implicit conversion only occurs when things can be statically casted to something with a 0 at the end. And so with dynamic strings, like this body string that we made up here at the top by concatenating hello 5 times, that does not implicitly convert, right? So if I try to compile now, it'll complain. Dynamically computed strings do not cast the pointer to U8, only literals do. So I think that's a pretty self-explanatory message. Of course, in this case, there's an overload because we had to print bytes in the library. So anyway. I think that's all there is to say about this. Like I said, nothing earth-shattering here, but just some decisions that were made to ease our everyday use cases. Sometime soon, we will do a demo of bigger features. I think the next bigger feature is going to be explicit namespace management, like declaring. Like right now, there's namespaces, but they're implicit, like, and they're associated with files. And so I think being able to declare a namespace off on the side somewhere and explicitly poke names into it is going to be useful. So that may be the next demo. I don't have a time frame on that. So I see a bunch of questions. Let me get to those. Oh, wait, those are all questions. Do we need something like makefiles to make builds? Ha, 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 no. There's a whole demo of that. Several demos of that. Why not encapsulate varargs in brackets to make it more clear? I don't see why that's more clear necessarily. Again, we're not that worried about syntax right now. The syntax for any of these things may change. What we're designing is like one layer more abstract than the concrete syntax. By function inside structs, I meant like how C++ deals with member class functions. No, we don't do that. This is not a object-oriented language. Do we distinguish wide and non-wide characters for strings? Is that only relevant when working with C++? Okay, wide characters are a Windows-only abomination that I would prefer die sometime in history. So we are not going to support them as native. You can certainly convert something to wide characters at compile time using a run directive if you want. But we're not going to like put a suffix, like Windows has something like, you know, T quote whatever, where that'll turn it into a wide string. We're not going to do that. Because wide strings are stupid. The only non-stupid version of wide strings would be UTF-32 strings. But UTF-16 strings are super stupid. So we're not going to do them. The end goal is for the compiler to support Unicode everywhere very cleanly, but it'll be UTF-8 as the native encoding. This UTF-16 thing is bananas. Yeah. What if your string has null characters in it? Well, if you have a string with a 0 in it and you pass that to C or C++, it's going to think that it ends at the 0, which may be what you want, right? But you should know that. I mean, that falls into the category of just, do you know what your program does or not? Like, I don't see how there's a problem there. But maybe I'm not thinking about the exact case you might be thinking of. If you explicitly place the terminating 0 in a string literal, will there then be 2 zeros in a row in memory? Yes, there would be. Again, we don't do magic. So if you put a 0, maybe you want there to be 2 zeros, right? I don't know. I don't know what you're doing. So yeah, we always put a 0 without question. Have we done any performance benchmarks recently? Nope, we have not. Could you try the while array question? Okay, let's do that. At the bottom of this demo, we're going to say the while array thing. We're going to say A is an array of int for 1 to 10 array add a it, right? And then while A array remove we'll just print it to do something and then array remove it. That should work. We'll see if I made a grave error here. This is, I believe this is what you were asking. So let's see. Oh, I've got to comment out my print bytes thing so that we can compile. Sorry. Wait, what now? Undeclared identifier array remove? What? Did somebody change things? What? Oh, unordered remove, right. So I named this, instead of naming this array remove, I explicitly named it unordered remove to remind you that the fast version of this will scramble the contents of your array. So we're not going to see these come out in the 1 to 10. We can, I believe there's an ordered remove. Yeah. So we can ordered remove by index, etc. All right. So there we go. 1, 10, 9, 8, 7, 6, 5, 4, 3, 2, and then we terminate. So that works. We can do an ordered remove, which is slower because we're going to pop everything back. In fact, we can do it by index. We can just say 0, right? So I never called this function, but every time I pop the message boxes up, I think it's a Windows crash, but it's not. So now it's ordered, right? And because it's ordered, we're paying more CPU here. That's the only difference. But yeah, you can totally do this. We're at Q&A, yeah. Say I declare a variable a string constant, call it a. If I do a.data plus a.count, do I get 0 guaranteed? Yes. So the question is the following. Oops, I got to do this. The question is the following. The string assertion S is, well, we'll say colon equals hello sailor, right? Last is, well, you can say the following thing. You can say S of S.count, right? Or you can say the way the question was phrased was dereference S.data plus S.count, right? These are the same thing. Get ready for some message boxes. Whoa. All right. Of course, this is an array bounds check failure because we're going beyond the end of the array. All right. So if I turn off array bounds check, then yes, you see that. Actually, this is an array bounds check failure. This is not, because we're dereferencing a pointer, right? So I can get rid of no ABC if I just do this. Right? No array bounds check failure. Any issues with non-English characters without Y? No, UTF-8 covers all of Unicode. In fact, it does that better than UTF-16. So UTF-8 is really pretty much the right thing. Unless I missed it, there was no example of verargs of differing types. Is that supported? Yes, it is. There is a type called any, and you can make a verargs of any, and then people will be casted to that in a way that provides type information so that at runtime, you can even query what type they are. And that was demoed years ago. It was the very first kind of verargs that we supported, actually. That's how print works, right? So let's look at that. When you call print, you need to be able to pass an integer or a float or a string or a struct or whatever. So we say this is a verargs of any, and there you go. Do I expect programmers in China and Japan to use UTF-8 to encode Chinese characters? I don't know what people in China and Japan typically do. But I don't see, UTF-8 is just a file encoding. It doesn't have anything to do with how you type things, right? If you type a Chinese character, it's like up to your editor how that gets stored. It's not something that the user does, right? But again, I don't know what file formats are commonly in use in China and Japan. If you do end up changing the syntax significantly, how capable do you think the compiler would be at automatically upgrading all the code you've already written? Our plan is to make that flawless. We can certainly update your program already because we have type information at compile time for everything. So we can do very strong upgrades. They're not just textual rewrites, they're semantic rewrites. However, we don't preserve your formatting right now. If we were the Go community, we would just say, fine, we're going to dictate how you format your program, but that's not really what we're about. So, you know, we want to do more work on preserving formatting, but we can certainly output a program that is semantically the same, that has different spacing on it. Already, I mean. Will people be able to make their own tag like no ABC that you just used with a meta program? There already are tags that you can put in called notes, and you could use those to do compile time code manipulations. So yeah, they just don't use a hashtag, they use an @ sign. But yes, you could do that. What are your thoughts on including basic functional programming idioms, EP, map, filter, reduce, head, tail? You can already do all that. We demoed that years ago. You can do stuff like map better now because now that we have temporary storage, you can essentially do leaking memory allocations that don't actually leak. So you can just call map on some stuff and just forget about it, right? Which is what makes map powerful. Like the reason you can't really map all the time in C and C++ is because you have to make sure to clean up all the memory. And here we don't care because we have temporary storage. So it should work better here than it does in many imperative languages. Since there can be more parameters after a varargs, will this work? Func ... A string ... B string. No, people were asking that before. We don't currently support 2 varargs parameters. So you know what he's asking is, several people have asked this. Whoops, I'm in the wrong file. Several people have asked this, so I'll just make it clear. He's asking about, can you do this? Or whatever. You know, A and B could be the same types or different types. And right now the answer is no. I wonder what happens if I try to do this. Yeah, can only declare 1 varargs argument per procedure. Now, this is not really a technical limitation. It's a little bit because it's a little bit more of a headache for us to track an arbitrary number of varargs parameters versus just 1 in terms of our own internal data structures. But we could do it if there was a strong need. It's just, I don't know if there's a strong need. And, you know, when it comes to exerting effort on the language design and implementation, there's a law of conservation of effort, right? So effort we spend on this doesn't go to something else. So if it starts to seem useful or important that we would do this, then we'll do it. But if it's just a stupid thing that we could just do it because we can say that we did it, then version 2, right? Or something like that. So we'll see. You meant that UTF-8 is kind of a bad choice in Asian text as far as you can tell. Why? Do you mean that it tends to be more than 2 bytes per character, or do you mean some other reason? Is it possible to have optional verargs? Verargs by default are optional. Let's see what happens. I mean, you can always pass 0 arguments for a verargs, right? I actually don't know. So the problem is, if you do this, that's ambiguous, kind of. But again, my philosophy on all these is there's no such thing as ambiguity usually, anyway. Yeah, I mean, this is actually a wrong error because this is a constant value. We just never considered this situation, so we're not looking for it yet. I don't know. Send email to the following address about whether this kind of a thing makes sense or not. As always, the place for comments is this address. It's not a mailing list. I do read everything that goes there. I don't respond to most things just because I don't have time. But you can send comments, questions, exclamations, explanations, and so forth to that place. So it sounds like your system would allow for more frequent language updates post-initial release, which is already a huge improvement over languages like C++ that, well, you add features rather than dare replacing things, right? Yeah, the plan is to make it easy for you to upgrade. But we also don't want to strain that. We want to get things pretty good the first time so that you don't feel the need to upgrade to the next version of the language. So we'll see how that shakes out. Is the any type supported in the reduced embedded mode of the language? If not, how can a function like print be implemented? It is supported, yes. It's hard to explain. I mean, I covered it way back. But what happens in the embedded version, like if you type, there's a compile time option, I forget what it's called, but it's something like, you know, no runtime type information or something, right? Then you still get an any argument to your print, but the type information on it then is an opaque handle. It's not a struct that you can dereference to find out more things about the type. So you would know if something's an integer, you would know if something's a string and so forth. You just, like if it's a struct, you wouldn't know what struct it is or what the members were or anything like that. You would lose that capability. And so, you know, right now, our version of print, if you print a struct, we assume you're not embedded, so we would crash if you printed a struct there. But it's probably not that big of a deal to have a compile time static if that says, you know, if we're running embedded, just print it's a struct, right? We just haven't done that. Can you force inline a compile time known function pointer call? We actually don't do force inlining yet anyway. Like, we claim that we do, but it's just not implemented yet, actually, right? So, like, we do all the type checking for it and stuff, but when it comes to generating bytecode, we just don't inline things yet. When we do that, then yes, we will inline a compile time known procedure call, pointer, whatever. It's not really any different from anything else that we would do. What is a replacement for virtual functions? I think you use some virtual functions in the witness. What would you do here instead? Well, you know, you can explicitly make a vtable, and you can say using that vtable and stuff. It's slightly more verbose than the C++ version, but you can do that. And then the bonus is there's no hidden magic. And I demoed that way back in the demo on YouTube that covers the using keyword. So you could go watch that if you're curious. How does memory for the dynamic array type work? Do you need to explicitly free it? Well, it uses whatever the allocator is that's set in the context. Again, we demoed that in a previous YouTube stream. Just look up the compiler demos on YouTube to find all of these. Normally, you would need to explicitly free it, yes, but it does take whatever the allocator is. So if that allocator is the temporary storage allocator, or if you explicitly assign the allocator on the array to be the temporary storage allocator, then you don't need to free it explicitly, right? In the temporary storage demo, we show that as well. Will the x64 backend ever have an optimization pass? Well, our bytecode engine will have an optimization pass, which then would carry over into any backend. Whether we will ever have a peephole optimizer on the x64 assembly code, I think that's the kind of job we would outsource to LLVM in the short or medium term. Long term, probably yes. Long term, probably we do everything in-house. But in the spirit of being able to generate fast code sooner, then we probably let LLVM do that for the next couple years. Do you have someone or people who you plan to have write documentation? Yes, we're going to have good documentation, unlike everybody in the open source community. Although we will not necessarily have very good documentation for our early adopters. We'll have some. But part of the point of having the early adopters is to figure out what they get stuck on, what's confusing, and what we need to document well. So, yeah. If you retain text spans corresponding to where the file a particular node came from, you could replace that text span in the file. It's actually a decent user-level feature. Also, for new syntax or syntax changes, you're inserting code with default formatting, but could you leave the rest untouched? Yes, that is actually the plan. So right now, our lexical analyzer doesn't give you the full range of where an error happens. It just gives you the start point of a token. And that's annoying, you know, if even before you talk about user code browsing or conversion in the syntax tree, of something that operates on the syntax tree, I mean, just for printing error messages, right? If we know the full range of something, we can draw that highlighted or something like that in a nice way. And we can't right now. You know, we draw this stupid little arrow caret thing it's actually at the end of the token. Sorry, I said the lexer gives you the beginning, but I think it usually gives you the end. It's just not good right now, but we're going to make it good. So you're going to get the exact range in the text file corresponding to that thing, and then something like a block, of course, that's not one token will give you, you know, the beginning of the block and the end of the block. So yeah, that is our plan, and that'll get us most of the way there for the text file conversion. And then, as you say, we can output most of the file verbatim, and then just for the things that need to be converted, we can only swap out those. And then we can still try harder to replicate the original formatting. All that said, the first syntax pass, for all I know, might be very drastic. It might touch most of the lines of code. So, you know, that leave the rest of it untouched may not come into play until later versions of the language. We'll see. Do we have slices? Can you do something like sum array 0 to 4 to get a view of the first 5 elements of sum array? Yes, that is what this is and this. We don't use that exact syntax that you're talking about, but you can call a procedure that gives you a slice into an array, yes. All right, any final questions before I log off and take a break, and then maybe we'll do a game programming stream? No off-topic questions right now, just on-topic, please. yeah, I'm glad you guys are enjoying the streams. I'm enjoying doing them. Will we ship with OpenGL bindings? Yes, we already have them. So, I don't know if you caught these streams, but this game right here that we are making in this language renders using OpenGL right now. And we have a GL bindings file. And we also have, it doesn't have everything in GL. We're probably going to gradually expand it until it has most things, but things that are super deprecated, maybe we won't add. Maybe this will be like a GL3 plus file or something. We also have Direct3D11. Look at all those constants. Look at all these vtables and structs and stuff. So Ignacio has been doing this, and that's great. So he has a Direct3D11 sample app that draws a triangle. Look at all that, man. He was much more thorough with his D3D11 than I was with my GL bindings. Let's just say that. SDL2 bindings are being considered. Do I have thoughts on that? Well, hey, look, it's SDL bindings that Ignacio also did. A lot of them are commented out. This is incomplete. Actually, no, that's just the compiler being confused. These are not commented out. Or it's just Emacs being confused, sorry. These are all valid. Well, most of these events are not here, but keyboard events are, and, my official position is that, I don't want you to have to use something like SDL. Like, I want our standard library that comes with the compiler to be good enough that you don't need this. But if you want to port some SDL code to this language, or if you just like SDL, if you prefer it, then yeah, we can provide bindings for you, and those are here. All right, everybody. Thanks for coming by. And like I said, hopefully we'll get back to implementing some bigger features soon, and I'll let you know when we're ready to demo something new. If you called some C code that ends up seg faulting, how do you handle the seg fault? The language does not have a policy on that. That would be down to you doing something operating system specific to catch the exception, which you can do, of course, right? Thanks for coming by, and I'll see everybody later on. You have SDL bindings for Odin, and given the syntax is very similar, do you think it would be very useful if I sent them to Ignacio? Maybe. That might be. I don't know how far along he is. I don't know what percentage of SDL is in this file. It looks like a lot of it, but maybe it's not a lot of it. It's 800 lines. Have I got mGUI working yet? Well, I use mGUI in the game, not dear mGUI. We have our own mGUI. Didn't you see the launcher box thing, man? Dude, we have a launcher box. So I hope it probably doesn't compile because we changed some things. Let me see. End of stream thing. Whoops, what? I didn't run the compiler, I ran the game. No, compiler. Oh, is it not first? Oh, source. Okay, we're using some deprecated set window long A stuff. That's why we marked them deprecated, but it looks like it built. Let's see. Run tree launcher box. All right, so this is mGUI. It's not a very fancy mGUI, but we're working on it. We're making a library. We've got checkboxes. We've got buttons. You went dear mGUI specifically. Nah, that's Omar's library. It's his thing. Compiler size. Can't type. 40503 lines of code. Was there a conclusion on how to handle external libraries, modules, imports? If so, which video do I need to watch? No, I mean, there was a libraries discussion a month or two ago. If you remember that, that's the last word on that. The next word will come when we actually start implementing namespaces and tackle these specific problems. All right, good night, everybody. See you in a bit. See you in a bit.